In this video, I'm going to show you how to propagate uncertainty through a power function, and then I'll show you how to add error bars to the raw data graph and also to the final linear graph when you're doing a lab report or a lab exercise. Those are the only two which require error bars: raw data, final linear. Okay, so here's my raw data graph for this first experiment. You all linearized 5. Make sure you have error bars on the raw data as well as the final linear. Alright, here we go. Error bars reflect the absolute uncertainty. So my vertical error bars need to reflect the absolute uncertainty in d, the diameter, which is 0.05 meters for all those values. And my horizontal error bars have to reflect absolute uncertainty in age, which is 0.1 years for all of these values. So I right-click. Oh, no, I don't. With the new Excel, I hit this little plus. I select my chart. I hit plus. I click error bars, and there they are. But those are the wrong values. I have to manually fix the values. So I right-click on the error bar, and then I hit Format Error Bars. Okay, let me move this over. Right now, vertical has been selected, and that's D, the diameter. So I want my vertical error bars to reflect 0.05 meters for all of those values. So it's a fixed error bar for every single data point. And the fixed value is 0.05. So I choose fixed, I plug in 0.05. I hit enter just to apply those changes. Now I'm going to click on the horizontal error bar and watch that when I click on horizontal error bar over on my graph, this will change, this heading. Watch this. Horizontal error bar. Beautiful. My horizontal error bars need to reflect the absolute uncertainty in age, which is plus or minus 0.1 year for all these values. So it's a fixed, it's the same for all of these data points. And hey, it's already on 0.1. That's nice. Enter. And then I'm going to take this away. Whoa, those are really small horizontal error bars. I would probably say somewhere in my lab report, the horizontal error bars are too small to be seen. Definitely, not probably, I would definitely say that in the lab report when doing an IB Physics lab report. Okay, now it's time for, this is my final linear graph. I fixed my equation, I changed it so it reflected my x and y quantities, and that 0.25 is the slope, so it has units of meters, y units over x units. So the units are meters per year to the 0.5. And I'm going to highlight this and then do Control-Shift equals to make it exponent, or to make it superscript, rather. Okay. Why not? Clean it up. Alrighty then. So now that I've got this one, I need vertical and horizontal error bars. Check it out. My y-axis is still distance. So the vertical error bars are still 0.05 meters. Because this quantity, the y quantity, is the same here as it is, as it is over here on my raw data graph. There's no difference. But this x quantity is different, right? The x quantity, let me take away some of these decimal points. The x quantity, and look, this fixes too. The x quantity is age to the 0.5, and whenever you raise a measurement to a power, there's a rule for propagating the uncertainty. So I'm going to move this down, and in these columns we're going to propagate the uncertainty. We're going to say, okay, if it's plus or minus 0.1 year in this measurement, then what's the uncertainty in age to the 0.5 power? You may recall, you have to take that power and multiply it by the percentage uncertainty in A. So the first thing I'm going to find is the percentage uncertainty in A. And I'll make a column, percentage uncertainty in A. And I'm going to highlight A, my variable. I like to italicize variables. And percentage uncertainty in A has no units. This, I should probably go in and fix the units to years to the 0.5. Okay, so I'm going to calculate in this column the percentage uncertainty in every one of these ages. Percentage uncertainty is absolute uncertainty, which is 0.1 for every single value, over the measurement. And you know what? Excel can put this into a percentage for me right there. Good. And I'm going to center so it looks nice. And bring this down. And for these, I want 2 sig figs. Since they are less than 2, equal or less than 2, these all have 2 sig figs as well because they are less than 2%. If the percentage uncertainty is greater than 2%, then you round to the nearest whole number. Now that I have the percentage uncertainty in A, I'm going to next calculate the percent uncertainty in A to the power of 0.5. So I'm going to make this superscript just so it looks fancy, because I'm so fancy. You don't even know. Alright, and now, how do I find the percentage uncertainty in A to the 0.5? I take the uncertainty in A, and I multiply by the power, 0.5, like that. And now I'm going to copy this down. This is a percent, so let me change it to a percentage. These need another sig fig. They need 2. Good. That's small. That's a tiny percentage uncertainty. Wow. So, can I put the percentage uncertainties onto this graph for the horizontal error bars? No. Error bars show how far over measurements could be. What's this doing here? Error bars show you the absolute uncertainty. So I need to take this percentage uncertainty and change it to an absolute uncertainty. What's the absolute uncertainty in A to the 0.5? Here's how I'm going to write that. I'm going to take this D superscript this, and I'm going to say in this column what I have now is the absolute uncertainty, so I'm going to insert the symbol for absolute uncertainty. Absolute uncertainty, let's make that times New Roman in A to the 0.5. So you may recall, here's the equation. Percent uncertainty equals absolute uncertainty over the measurement. So if you're solving for absolute uncertainty, it simply equals the percentage uncertainty times the measurement, or the value. So here, I'm going to calculate the absolute uncertainty in A to the 0.5. I'm going to calculate ABS here, absolute uncertainty, by multiplying together the percentage uncertainty and the measurement of A to the 0.5, or the value of A to the 0.5, like that. And I'm going to copy this down. I need all of these to have 1 sig fig since they are absolute uncertainties. And these need 1 fewer sig figs still. Alright, let's center that. And of course this has units, so I better plug that in with my into my heading, my column heading. The units are years to the 0.5. And if you are doing a real lab report, you can make this look pretty, you know, make that superscript. Don't use the caret in a real lab report. But for this exercise, you can make it look ugly, that's fine. So these are, this column tells me the absolute uncertainty in A to the 0.5. That's what I need as my horizontal error bars. Let's add in those error bars. I'm going to click on my chart, my graph, hit the plus, check the error bars. I'll do the horizontal first. I right click, format, and the data points have different values of uncertainty, right? So it changes. Let me move this over and get rid of this. The data points all have different values of uncertainty, so, whoops, click on it. So I went horizontal first. Horizontal, good. So instead of having a fixed value, I need to specify a custom value for all the different data points. I hit specify value. The positive error values are these. It could be plus that amount, and negative, it could be minus this amount. Right? And when I select an entire column, Excel automatically pairs this as the horizontal error bar for this first data point here. Where is it? Here. Here's the x value. And it pairs this horizontal uncertainty with this x value, and this horizontal error bar, or uncertainty bar, with this x value. And it does that all the way down. That's cool. So I hit OK. Then I choose, and look at how small those horizontal error bars are. They are too small to be seen in this case. But you're still going to print out this stuff, so I will be checking for the correct work. You can't just fail to put the error bars on and then say they're too small to be seen, because I'll check this and see that you've done the work correctly. Okay, funny little thing there. Next, I have to change the vertical error bars so that they reflect the absolute uncertainty in the y quantity. My y quantity is d, diameter, and the absolute uncertainty in every diameter is plus or minus 0.05. So I choose vertical. Now this shows vertical error bars here. I go down and I change it to a fixed value of plus or minus 0.05. Enter. And now I am finished. That is my, these are my final graphs with the correct uncertainties shown.